In other videos, I showed you how to convert a regular expression to a DFA using some kind of holistic rules that a human can follow fairly easily. But if you're a computer, you need something more systematic. You need an algorithm to follow, and for an algorithm, you need a very specific set of rules and a very specific set of steps to follow. So if you want to convert a regular expression to a DFA, you actually need to do it in two steps. You need to convert a regular expression to an NFA, and then convert that NFA to a DFA. This video will handle converting the regular expression to an NFA, and then other videos will handle converting the NFA to DFA. So the rules you need to work with when you're converting a regular expression to an NFA are as follows. You've seen a couple of these before, but one of them is a little unusual. The first one is that if you have a regular expression A or B, it is represented using two states and two transitions that go between those two states. One labeled A, the other one labeled B. If you have a regular expression A followed by B, that's done with three states, two edges between them, and the first one's labeled A and the second one's labeled B. And then finally, if you have the regular expression A star, that's done with four states. The A goes between the middle two, and then there are epsilons between the others. Like so. And these epsilon transitions allow you to represent 0 or more A's. So the problem we're going to start solving is x or yz. Now to solve this, you first need to recognize that this is not x or y followed by z. This is x or yz. In other words, the yz are kind of like in parentheses. So what I see here is I see the regular expression x followed by yz. So it's kind of like A is the thing on the left and B is the thing on the right. And that shows that the rule we need to apply first is the A or B rule. So we're going to start by drawing two states and two transitions between them. And the first one we're going to label x, and the other one we're going to label yz. And then the next step is to break down the yz into its components. So I'll kind of reproduce that down here. We have the x going across the top, and then the yz has an intermediate state. Just like that. Then this becomes our beginning state, and the one on the right becomes our accepting state. And that's how you do that. So x or yz is converted into an NFA using this. And although this actually looks like a DFA, you know that any deterministic finite state automaton is also a non-deterministic one. So this is actually an NFA as well. Okay, let's do another one. How about if we do w or x, and then that whole thing is star. So to solve this one, we need to break that down, and what I kind of see is the w or x is kind of like our A, and so we have the rule we need to apply is the A star rule. So we'll start with that. Four states. The first two get the epsilons, and the middle one is labeled w or x, and then we'll just put in our other epsilons here. And the one on the left is our starting state, and the one on the right is our accepting state. And then we just need to break down the middle one. So I'll just draw it down here below. Let's see, epsilons here. The middle one becomes two transitions, one labeled w, one labeled x, and then we just need to finish off with our epsilons, and then draw the one on the left as the starting state, and the one on the right is the accepting state. So here is the finite state machine for w or x star. Okay, and we'll do another one. this one would be a little more complicated. Let's do A star B C. Now in this one, what I see is the A star is like our A, and then the B, well, the BC, we'll make that our B. So there's kind of two parts, and I could have split it up another way, but this one works pretty well. So we'll draw that as three states. The first one is A star, and the second one is BC. And now we just need to split up each one of those. Let's start with the A star. So this whole thing right here, this piece here, needs to be split up into 4 states. So that becomes 1, 2, 3, 4. The A goes in the middle. Epsilon here, epsilon here, epsilon all the way across, and then 1 coming back. And then the BC becomes 2 states, BC, and then finally here's our starting, and here's our accepting. So this here is the solution for A star BC. And the last one I'm going to do, I'll do this one down here, is we're going to do J star or KL. Okay, so again, break this up. I see an A and a B here. So we'll do top is J star and the bottom is KL. So let's break that up. Oh, here's our starting, here's our accepting. So the J star needs to become 4 states, so I'll leave a little extra space for that. Here we go. So the first is epsilon, then here's our J, and then an epsilon, and the bottom one becomes KL, and then we need, I need to forgot two more epsilons here. So here's the one that goes all the way across. That's the equivalent of this one right here. And then we need one more, which I almost don't have space for, but I'll kind of cram it in here. But it goes all across like that, and that's labeled epsilon there. So here's the solution for J star or KL. We got J star across the top and KL across the bottom. There you go.